squared equals 25, c equals 5, so the hypotenuse is 5 centimeters. That's one question done. Can I help you? You've been gormlessly staring at me like the whole lesson. What am I doing? Look around you. I'm doing math. We're in a math class. You know how to do it, right? It's Pythagoras' theorem. It's quite simple. They teach it in like year 10 secondary school. You need help? Oh. I guess I can waste a bit of my time on a lost cause. I know it's a big name, Pythagoras' theorem, but it's just the name of the guy who invented it, or discovered it even. It's not as big and scary as it sounds. It's just triangles. Triangles are fun. Triangles are easy. We love triangles, mostly. So, I'll show the question I just did, I guess. So, the general rule of Pythagoras' theorem. First of all, let's do it with right-angled triangles. Right-angled triangles. That's a triangle where one of the angles is 90 degrees. And opposite from that 90-degree angle, we have the longest side of the right-angled triangle. That's the one that goes diagonally across. We call it the hypotenuse. And the goal of Pythagoras' theorem is to find the length of the hypotenuse using the measurements of the other two sides. So this short side here, the height of it, we're going to call that side A. The longest side along the bottom, we're going to call that side B. And the longest side, the hypotenuse, the one that goes diagonally, we're going to call that side C. Now, the formula that we use for Pythagoras' theorem is A squared plus B squared equals C squared. Getting this? Maybe I'm not as much of a lost cause as I thought. I'm keeping my eye on you. Anyway, so let's say, for this example, that A is 3 centimeters and B is 4 centimeters. How do we know these values? Because I just told you them. How would we know them in the real world? By measuring them. It's that simple. You just know them. The whole theory works around the fact that you just know them. So, for this example and this example only, A is 3 and B is squared plus b squared equals c squared. So if a is 3, then what is a squared? Perfect, 9. 3 squared is 9. And if b is 4, then what is b squared? 16. Perfect. Now, you have to add a squared and b squared together to get c squared. So what is 9 plus 16? 25. So now we have that c squared equals 25. But we don't want c squared, we want c. So what do we have to do to c squared to get c? We have to square root it. We have to square root c squared to get c. So we have to square root 25 to get c equals 5. And that's it. The hypotenuse of this triangle is 5 centimeters. And this particular question is quite simple, straightforward, because we call it a Pythagorean triple, because all three numbers are whole numbers, whole number being when there's no decimal place. So 3 is a whole number, it doesn't have a decimal. 4 and 5 also whole numbers. It's not always the case. We're going to go on to a different example, a more random set of numbers that we might need a calculator for. So we'll go with, well, let's draw the triangle out first, shall we? So here we have A we'll say is 4 centimeters, and here is B we'll say is 6 centimeters, and then we have C, the hypotenuse. You don't have to know the word hypotenuse, it's just a fun word. It's not really that important to learning Pythagoras' theorem. But I mean, come on, hypotenuse. Say it with me, hypotenuse. Hypotenuse. Anyway, fun word. And we'll write the formula again. A squared plus B squared equals C squared. Now, what's A? It's 4, yeah. So what's A squared? 16. You're getting it, you're getting the hang of it. What's 6? What's 6? What's B? It's 6. What's B squared? 36. So 16 plus 36 equals C squared. What's 16 plus 36? Counting on your fingers. This isn't primary school. Yes, 52. Good job, I guess. So C squared equals 52. Now, this is the part where we might want to whip out our calculators or our phones, because who owns a calculator in 2026? And we might want to do some square rooting, because I don't know about you, but off the top of my head, I don't know what the square root of 52 is, and it's probably quite a lengthy number. Yeah. So the square root, according to my calculator, the square root of 52 is 7.211102550927. I can only imagine it keeps going after that, but that's what it says here. So that's the length of C. Of course, we can round it to 2 decimal places, so C equals 7.21 centimeters. Boom. So, do you know what you're doing yet? Do you understand, or do you just like the sound of my voice? Bit of both? Okay. Well, I think that's enough for you to get on with your work, and me to get on with mine. So, you need a pen. You think to, I don't know, bring your own. It's a classroom. You kind of need a pen. Alright. I suppose I can spare my pen. But I want it back by the end of the lesson. And don't chew it. I'll chew you. That came out wrong. Forget I said anything. You got this. I can't seem to find myself again. My walls are closing in without a sense of confidence. I'm convinced that there's just too much pressure to take. I've felt this way before, so insecure, crawling in my skin. These wounds, they will not heal. Fear is how I fall, confused. Oh. Looks like it's time to peer assess. Let's see how you did. I'm sure you nailed it after my teachings. hasn't sunk in. What is this? A spiderweb doodle at the bottom of your page. Seems like time well spent to me. Well, that was a bit anticlimactic. I gotta say, I expected better. But, I mean, I'm sure we'll get somewhere in time, maybe next time. Maybe a few study sessions, you'll get somewhere. Here you go. Oops, sorry, all your stuff fell out. I'll leave you to get that off before yourself, because, I mean, probably not that important, right? Yeah, but, yeah, I think we'll get somewhere. I mean, a wrong answer is better than no answer at all. So that seems like progress to me. You did not. Don't remind them about the homework. You did not just remind them about the homework. No, of course I didn't do it. Nobody does it. They never remember. Why would we do it? I mean, it's just... Did you do it? How? Let me look at that. How'd you get it right? You just like pretending to be dense? You got your sibling to do it for. Of course you got your sibling to do it for you. Not all of us can just get some whiz sibling to get it done for us. Yeah, no. Looks like it's detention for me. Oh well. Yeah, no, I didn't do it. Yeah. Oh well. Anyways. Looks like that's lesson over. Yeah, I've got to stay here and do the homework that I missed. Seems like, looks like. Easy stuff anyway. It's just calculating the area of a circle. Should be nice and straightforward. I'll catch you later. No, you're staying through the detention. Well, I guess it's true you didn't do it either. So, guess I'm stuck with you a while longer then. Should we go through it together? Right. So, circle, and it's telling us that the radius of that circle is 12 centimeters. Not the radius, the diameter. It's telling us that the diameter of that circle is 12 centimeters. So you've got the circle, and the diameter is like, if you were to cut it in half, it would be the length of that cut. I don't know how to explain it. It's like if you drew a line straight through the center of that circle, it's the length of that line. You get me? You get me. So, diameter's 12 centimeters in my very well drawn diagram that you can't quite see. But you get the picture. Now, the radius of a circle is half the diameter. It's like if you started at the center of the circle, center, and then you went straight up, or in any direction straight towards the outline of the circle, what would the distance be? So it's obviously half the diameter, which in this case is 12 centimeters. So the radius is 6 centimeters. Now, do you know the formula for the area of a circle? The formula for the area of a circle is radius squared. That's my pen on the floor. 1 second. Let me just get that. I need a cough sweet. Pardon me. So, the radius squared multiplied by pi. So, and obviously pi is 3.14 whatever, it goes on forever. You just pop it in a calculator and it gives you the answer. So if the radius is 6 centimeters, then the radius squared, right, let's write the formula. Area equals r radius squared multiplied by pi, which is represented with that weird N-like symbol. I can't really draw it in the air, it's too hard. Pardon me. The radius squared equals 36 centimeters. So, the area of the circle is 36 pi centimeters squared. So, now we need to find out what 36 pi is. 36 multiplied by pi. It is 113.09733555292. We're gonna simplify that to 113.097 centimeters squared. Sorry, I'm really not very well. Try not to cough on you and get my icky germs everywhere. This shirt is not helping, it's very asphyxiating. So yeah, that's the area. The next question here is what if it were a cylinder? What if that circle was a cylinder? And what if that cylinder had a height of 10 centimeters? What would be the volume of the cylinder? So to find the volume of the cylinder, we already have the area of the circle that makes up the cylinder being 113.097 or 36 pi. But obviously now we're talking volume, not area. It goes from centimeters squared to centimeters cubed because it's not 2D anymore, it's 3-dimensional. So we're cubed now. This is really strangling me. So we just take that area, change it to centimeters cubed, and multiply it by 10. So the volume of the cylinder is 360 pi centimeters cubed, or 1130.97 centimeters cubed. Lovely stuff. But they also want us to find, as the final question, they want the surface area of the cylinder. We're going to run through this one quickly because break's nearly over. We've got this. So we have the area, 36 pi centimeters squared. We're going to double it because the cylinder has two circular faces. We want to find the surface area, so the area of all of its surfaces. It has three of those. The one on either end and the one that goes all the way around. So the one on either end, each one's 36 pi centimeters squared. So what are both of them combined? 72 pi centimeters squared. So we're going to take that, we're going to work with that. Now we just need to find the area around, which means we need to find the circumference of the circle that's around the circle. The circumference is the diameter multiplied by pi. The diameter, you might remember, is 12 centimeters. So the circumference is 12 pi centimeters. 12 pi centimeters. So the area of the bit around it will be the circumference multiplied by the height, which we know to be 10 centimeters. So 12 pi times 10, 120 pi centimeters squared, because it's an area. So we add 120 pi centimeters squared, which is, the area around the circumference. And take that and we add it to the 72 pi centimeters squared, which is the circle on each side of the cylinder. And we add them together and we get 192 pi centimeters squared as the surface area, which, if we run that through our calculator, 92 pi, we get surface area equals 603.18578948892, which we're going to simplify to 186, 3 decimal places, centimeters cubed. And that's it. Homework's done. Break is over. Go team. team. I guess I'll be seeing you next math class when you'll undoubtedly be needing my help again, because, well, you don't seem like you can do very much for yourself. It's been nice working with you, or I guess working for you. Hopefully you'll learn to do things by yourself. Soon enough you'll become more independent and confident at it. It takes time. And it's not the easiest thing to take in, especially when you have an inferior mental capacity. And I respect that. So take your time. We've got all academic year to nail this together. Just don't hold me back. See you later.